All right, so hello and welcome again. Let's do one more question for the night. This is going to be number of burgers with no waste of ingredients. Let me just make sure the audio is working. This is going to be number of. Very good. All right. So this is probably the last question for tonight. Let me just make sure I have everything ready before I begin. I think I got everything. Yeah, I think I can do this. Okay. Very good. Okay, close the previous question, open this one, and refresh there. All right, so let's see how quickly we could do this one. Number of burgers with no waste of ingredients. Okay, so this is given two integers, tomato slices and cheese slices. The ingredients of different burgers are as follows: jumbo burger, 4 tomato slices and 1 cheese slice. Small burger, 2 tomato slices and 1 cheese slice. Excuse me, my neck. Return total jumbo and total small so that the number of remaining tomato slices equal to 0 and the number of remaining cheese slices equal to 0. If it is not possible to make the remaining tomato slices and cheese slices equal to 0, return an empty string. Okay, so we can make jumbo burgers and small burgers. All right. Interesting. Output 1.6. Okay. To make 1 jumbo burger and 6 small burgers, we need 4 times 1 plus 2 times 6 equals 16 tomato, and 1 plus 6 equals 7 cheese. I suspect that this is a extended Euclidean algorithm question. That could be what it's getting at here. There will be no way to use all ingredients to make small and jumbo burgers, 17 and 4. Making 1 jumbo burger, there will be 16 cheese remaining, and making 2 small burgers, there will be 15 cheese remaining. Tomato slices, cheese slices between 0 and 10 to the 7th inclusive, so 10 million. So pretty low submission rate and pretty, okay acceptance rate, like sort of medium acceptance rate. Okay, or sort of mid level. Not too hard, not too difficult, but pretty large number of people skip this question. So first things first, 4 and 2, the GCD is 2. Excuse me, which implies that first things first, the tomato slices has to be an even number. Has to be an even number, otherwise it's not possible. And the second thing is obviously has to be a larger number. Tomato slices has to be an even number that's larger than the cheese slices. And I think larger than twice the cheese slices. I think if it's as long as it's an even number that's larger than twice the cheese slices, it's always possible to create. Now, okay, hold on. But what are the numbers they're looking for exactly? Why not? I don't know if it matters what I return. So here in this case, oh, there's one more issue though. The number has to be even. It has to be greater than twice the cheese slices. The number of tomato slices has to be greater than or equal to twice the cheese slices, and less than or equal to 4 times the cheese slices. Those are the conditions, right? Those are the conditions. And in that case, you just need enough jumbo burgers until the cheese slices are equal to half the tomato slices. So yeah, we'll just check that. So if we'll just say TS and CS, just to keep it simple. So if TS, so we'll say it's greater than or equal to CS, and TS is less than or equal to CS. And we'll say if it's not those things, something like this. So there's one more detail. It's got to be, and it's got to be modulo 2. So it's got to be mod 2. It's got to be even. It's got to be even. It's got to be greater than or equal to 2 and less than or equal to 2 times CS and less than or equal to 4 times CS. And if it is, then we can just figure out, do some quick math here. I don't think I need to use anything really fancy. I don't think I need to use, what's that called? I don't think I need to use, what's it called? I don't think I need to use the Euclidean algorithm, the extended Euclidean algorithm. I think I can do this by hand. It's fairly straightforward. So we have A plus B. How does it work? It's going to be, let's say, some number of jumbo burgers, some number of small burgers. 4 times the jumbo burgers plus 2 times the small burgers is going to give me the number of cheese slices, right? Which is going to be C. And obviously that means that could divide Z by 2. So really any point on this line on this Pareto front, so to speak, any point on this Pareto front should work. The problem is that X and Y both have to be greater than or equal to 0. That's kind of the issue. And you could just say Y is Z minus 2X. X is the jumbo burgers. And so Z minus 2X has to be greater than or equal to 0. So that means that Z is greater than or equal to 2X. So that 2X is less than or equal to C. To say that ZX is less than or equal to Z over 2. That'll ensure, so X has got to be between these numbers. And then that implies that Y is greater than or equal to 0. So you could take any number X that's less than or equal to Z over 2. So you could say X is just the floor of C over 2. And then Y is going to be C minus 2X. Yeah, we don't need to get too crazy with this one. Don't need to do any extended Euclidean algorithm stuff here, so we'll just do yeah, X and Y in this way. We'll say X is Z bit shifted by, it really should be bit shifted by 2. Z bit shift equals, which is CS. Bit shift again is X, and then return X, and what did I say it was? Z minus 2 times Z over 2. That's CS. It's a little confusing, yeah, something like this. Something like this. Wrong. Oh. Oh, maybe it's not. Is this supposed to be equal to cheese slices? Yeah. Z is the cheese slices. Or is it tomato slices? No, no, no. Z is the other one. It's TS. Yeah. No, no, no. Z Z is CS. But TS has to be greater than or equal to twice CS, which it is in the first case. 16 is greater than or equal to 14. But it also has to be less than or equal to 4 times this 28, which it is in this case. And it has to be even, which it is. How did I get this? Wait, what? What is going on here? What? What is going on? What? This is otherwise correct. I don't know what's happening. Why? What? This is true. This is true. And this is true. What the heck? What's happening? Huh. Also, why is this happening? My tab's all messed up here. What is going on? Which part of this is wrong? Huh? Sometimes things happen, I don't really understand it. I really have to sit there and think about it or just print things out. This is true. Okay, why is it true? So if something here fails, I don't know which one of these fails. Okay. Try that one. I need to do this. Pretty sure all 3 of these should be true. Deep breath. Okay. Oh. Thank you, compiler. Thank you, compiler. You know, I've made that mistake before. I've made that mistake before. I don't think that's a good, still wrong. Oh no. What? Oh. No kidding. Shouldn't this be 4? Oh no, but it's the cheese slices. Yeah, I guess. What is going on? This is z over 2. Oh, that's why. I did that wrong. I did this wrong. I see. Okay. That's very wrong now. Yeah. I did that wrong. It's my bad on my part. I should have kept it as it is. So that way I'm not confusing my symbols. Alright. So y is z over 2 minus 2x. And then say z over 2 is z prime. So now y is z prime minus 2x. And then if we want z prime minus 2x to be greater than or equal to 0, then we need z prime to be greater than or equal to 2x, which is to say that x is less than or equal to z prime over 2. Right? 2x is less than or equal to z prime. Yeah, okay. And then, all right. X is less than or equal to z prime over 2, which means that x is floor of z prime over 2. So that was correct, but this part's wrong. Y is, this is not x minus 2x, it's z prime, which is cs, minus this thing times 2. Wait, what? No. What's c prime? What? What is happening? What is going on? Why? Oh, this. Oh my goodness. No. This is TS. I'm confusing myself. I don't know. This wasn't supposed to take so long. This is supposed to be very quick. Confuse myself. No. What? No. No. What is going on? No. Oh, this is so confusing. This is TS. This is not CS. X plus Y is equal to CS. You know, maybe I'm doing this wrong. Actually, maybe this should just be X plus Y equals. No. Well, no. I'm fine. I'm fine. Doing okay. I'm okay. It's just. What the heck? This goes to 8. This goes to 4. 4 and 0. What was wrong here? X has to be the. Okay, I think. I don't know what. I'm doing something very wrong here. Just getting very confused. I don't know why. What did I do? What is going on? So in this case, right? First things first, we can do this. Make things a little bit simpler. 2x plus y equals z over 2. Y is then z over 2 minus 2x. Y is greater than or equal to 0. Now, these are the small burgers, right? I really want the big burgers to be greater than or equal to 0. Those are the ones I'm really concerned about. So I should do it the other way around. I need x greater than or equal to 0. So then I need to say x is z over 2 minus y over 2, right? And to say that is greater than or equal to 0 implies that half z over 2 minus y is greater than or equal to 0, which gives me z over 2 is greater than or equal to y. Okay. So then y is less than or equal to 0 over 2. Just to say that y could just be the floor of 0 over 2. And that implies that x is greater than or equal to 0. And x is then a half of 0 over 2 minus y. Also implies that z is divisible by 4. Does z have to be divisible by 4? No. It just means that z over 2 minus y has to be divisible by 2. Does this work? Hold on, something about that doesn't seem right. Z minus y has to be divisible by 2? Really? I don't think that's correct. Doesn't seem right. Huh. But we could do it that way. Let's do y is z over 2. Are these big burgers or small burgers? We're going to find the small burgers first. We should find the big burgers first. Which is x. No. What? I did it right the first time. This is so confusing. This is not supposed to be this hard. Let's find an expression for x first, right? Let's find x first. So we'll say that y is, I had it right the first time, z over 2 minus 2x. Y is greater than or equal to 0 implies that z over 2 minus 2x is greater than or equal to 0. This gives us z over 2 is greater than or equal to 2x. Excuse me, z over 4 is less than or greater than or equal to x is less than or equal to z over 4. X can then be z over 4 floor, which is what I have here, right? We'll just keep it simple. Do it this way. Okay. And now y is z over 2 minus 2x. Which is this. Alternatively, just do this thing. Something like this. Wrong. What? Why do I keep getting 4? Why? This is wrong, right? Because x plus y has to be equal to z, x, y, z. We'll just say alpha. Oh, okay. X is equal to z over 2 minus alpha. Oh, and then y is alpha minus x. Okay. X equals z over 2 minus alpha. Let's try that. Z over 2 minus alpha. Maybe that's what I did wrong. This is not as easy as I thought it was. And then y is equal to alpha minus x. Maybe that's what I did wrong. You know, don't mind me. just not doing things correctly sometimes, I guess. Just oh man, I don't know. That shouldn't have been that hard. That was like kind of a math puzzle that I should have been much faster about that. Should have been way faster. That was not that hard at all. It's like a pretty basic puzzle. Yeah. Okay. And then, you know, something like this, some things of this nature. Let's see what we get. Okay. All right, let's try these things. I think I got it. I'm gonna go for it. I could be wrong, but I think I got it. Oh, got it. Okay, very good. So that's a constant time solution. You don't have those too often. Those are pretty unusual. That's very fast. Yeah, I mean, I don't know what to say. Like, okay. I took so long to do that. I took so long. It was kind of like basic algebra. I don't know. I'm ashamed. I'm ashamed. I'm not ashamed. I should have been able to figure that out in like a few minutes. It should have been a lot faster. I kind of just did the math wrong, I think. It's probably accurate to say. You know, just did the math wrong. Did the math wrong. Yeah, this I think guarantees that this is non-zero. And then this part also guarantees that this will be non-zero. Yeah, it's pretty interesting. It's kind of weird how I figured out those two things, but it's not, I guess not that hard to realize that. Weird that this is taking so long, the runtime. It's not just 0 milliseconds every time. It's literally like a couple operations. It's very straightforward. Could calculate these and just check that they're non-zero. Yeah, okay. All right, that's probably enough. So yeah, thank you for watching. If you like the video, give it a like and subscribe for more. Yeah, I'm definitely ashamed of that it took so long on those last two questions. It is what it is. I'm maybe not ashamed, that is shameful. It's just disappointing. those really weren't that hard. Those two both should not have been so difficult for me, but that's okay. This is why I practice, right? Sometimes you just don't realize it, see it, and it's important to practice to make sure you get it right in the future. So yeah, thank you for watching. I appreciate it, as I mentioned before. This is gonna be it for me tonight. I think that's gonna be it. I spent a few hours, got some time in. That was good practice. It's good to do. Yeah, let me stop here. So yeah, take care. Take care.